Hey there, it's Jason Gorman with the final video in our series on test-driven development in Java. If you've not seen the previous videos in this series, I highly recommend you take a look at those first. There'll be a link in the description below. Now, in the last set of videos, it was a two-parter on two different approaches to test-driven development, inside out and outside in. And what we discovered was that they both have their advantages and disadvantages. Inside-out design is better in some ways because our tests more closely pinpoint the sources of errors. So when a test fails, we can sort of see where in the software it's gone wrong, or where in the call stack, if you like. And that can be very useful if you're working on complex sort of multi-layered designs, which most of us are. But it has disadvantages. When we expose the internal design of our software, the internal details, we couple the test code a little too much to the implementation design, and that means that changing it and refactoring the internal design later is harder. And also there's a risk that when we sort of test drive pieces of a jigsaw and then try to put the jigsaw together at the end to satisfy a customer requirement, we can find that actually the pieces don't fit. With outside-in design, we drive our test-driven design process directly through an external interface or an API, and through the process of refactoring the internal design, we extract the pieces of the jigsaw to make our code more readable or to remove duplication and things like that. So the pieces are guaranteed to fit, and also we end up with test code that is more loosely coupled, knows less about the internal design, and therefore change going forward is easier. But it has the disadvantage that when all our tests are at that kind of API level, that if we have a deep call stack, if we have a complex multi-layered design, then we can end up essentially in the debugger trying to figure out where it's gone wrong when a test fails. Now, in this final video, we're going to be talking about two related topics, and we're going to be seeing how these techniques can be used to scale up the TDD process to these kind of complex multi-layered architectures that have external dependencies like web services and so on. And we're also going to look at how we can then use these techniques to drive designs from the outside in, but effectively kind of have our cake and eat it. So not all of our tests will be at the external API level, but they will be more loosely coupled, and we will have the benefit of making sure that all the pieces of our jigsaw fit. They're guaranteed to fit because we're driving our designs directly from customer requirements. So let's start by talking about external dependencies, and I'm going to use an example here of a community movie library, so people can donate their DVDs and Blu-rays to this movie library. And we have a requirement that we essentially, when we add a movie to the library, we donate it using the movie's IMDb ID. So if you're not familiar with IMDb, it's the Internet Movie Database, and it holds a lot of information about the movies. The information we require are the title of the movie and the year that it was released. So we have a requirement when we donate a movie to the library that we will look that up on IMDb. So this is an external data source. It's not data that's coming from our system. It's data that's coming from someone else's system. Now, we want to drive our business logic, the logic for adding the movie to the library. And we want to write a unit test that runs fast so that as a regression test, it's very useful going later. And also, I would like to defer the details of how we actually fetch that information. There's probably a whole can of worms around, unpacking JSON data and creating HTTP requests and all that kind of stuff. I don't really want to worry about that. That's a separate concern. And you'll see me using this phrase a lot over the course of this video. It's another concern, what I would call somebody else's problem. How do we actually fetch that data from IMDb is somebody else's problem. It's got nothing to do with how the movie is added to the library. All we want to know is the movie is added with whatever title and year IMDb returned for that particular ID. So how do we do this in a unit test? Remember, it's not our data, so we can't just pass the data into our donate method and go, there you go, there's the data, because we don't have it. We have to fetch it from somewhere. Now, in most languages that have some kind of dynamic binding, dynamic dispatch, like interfaces or duck typing or that kind of thing, it's possible to make dependencies swappable by dependency injection. In other words, if we can define an interface for fetching IMDb movie information, doesn't matter behind the scenes how that will work, we just define the interface and what it will do at this level. So the library will talk to some object that it gives the IMDb ID, and it gives back information in some form. For example, in the form of a hash map. Or in this case, in the form of a movie. So let's imagine this thing exists. Let's call it movie info. And this is going to be defined as an interface injected into library, so library can talk to it. Dependency injection, very much the mechanism here by which we make our dependencies swappable. And I'm going to work backwards from here. Let's create a local variable for that. And I'm going to define, I'm going to imagine there's such an interface as movie info. Let's declare that. Okay, and put it in our source package. Clever old IntelliJ. And now let's define our constructor. Oh no, actually it wants me to, let's just do that for now so I can get round to defining my constructor. Now here's where the rubber meets the road. My library only knows about this interface. It's binding to this abstraction. This is very Java specific, but it's binding to this abstraction for movie info. So it doesn't know anything about implementations. It just knows there's an interface for getting movie information. That's all it needs to know. Back to our test then. What we're going to do when we instantiate our movie info is we need an implementation now that will return our test data for the title and the year of the movie. So let's imagine that it's an implementation. We're going to call this a stub, and I'll explain what that means in a minute. Stub movie info. And I'm going to pass into this stub the test data that I defined here. So we can create this as an inner class. There we go. Yep, that looks good. So we're creating this stub movie info object, and a stub is what we call a test double. It's an object that looks like the real thing from the outside. In other words, in Java, it implements the interface that our library is expecting to talk to, but it has a hard-coded implementation, and its only job is to return whatever test data we tell it to return. That's all a stub is for. It just returns whatever test data we tell it to return. So it's part of the setup of this test. It's the beginning of our test, if you like. So it provides test data to library. Now, what we need to do here, that's enough to be getting on with. We've got a test that will currently run, but when I run it, what we're going to get here is an unhandled exception. Let's just run our test and see it fail. Any second now, while it builds it, cranking the handle there. Okay, so we're not getting as far as, so let's just, in our library for now, return a new movie. Okay, so it's not null. And what I want to see is I want to see those test assertions fail because the movie we're getting back doesn't match what we're supposed to have added to the library. Okay, now to pass this test, we need to do a bunch of things. First of all, in our library, we need to, let's just assign this to a field. Okay. And when we donate, what we're going to do is we're going to add to a collection, let's call it the catalogue. We're going to add to a collection this movie, and it has the information that is returned from our stub. So let's call that info get title, info, get year. Okay. And this info is going to be a map. So we identify the name of the field, and actually we'll also make this a string as well. And then what I'll do is convert that to a string. No, it's supposed to be an integer, so let's parse that. Parse int, is that right? Yeah. And this is going to be our info object. Quite a lot going on here. And we're going to use our movie info to fetch using the IMDb ID. So now we're going to define this method on our interface there, and then that will force us in our test to implement that method in our stub. Okay, so we fetch the movie info, and then we create a movie that uses that information. Let's create that instructor. Okay. And in actual fact, I think what we're going to do is we're going to make this a hash map. So what we'll use is we'll use the IMDb as the key for a lookup. Let's create that field for catalog. Let's make that a map, a string, and a movie. And we can instantiate that there. No, that's not what I meant to do. A new hash map, isn't it? Okay. Now, what we're returning here in Find Movie is just the matching movie, the one with that key. So a little bit of work there. And hopefully, let's declare that's final as well. Hopefully when I run this now. So we're going to have to implement our stub for this to work. There we go. Let's implement the methods for fetch. And now let's make our stub do its job, which is just to return whatever data we tell it to return. Okay. Put. So we put title. Year. String. Is it, in fact, trying to get my that's more like it. I'm trying to get my Java head back on, and then we return info. Okay, now that our stub's working, hopefully when we rerun our test, it should all work. And of course it doesn't, because in movie, yeah, so I'm implementing quite a lot here. I would have probably been better off triangulating this in Java, because we have to fill in quite a lot. Finally, okay, so now that's working. A bit of a step there, a bit of a leap, but hopefully you get the idea. So if we take a look in our test here, essentially what's happening is we're setting up this movie info stub to return the title and year that we tell it to return, so that we can test that a movie with that information is added to our library. That's the requirement. Doesn't matter how we actually fetch information from IMDb. That is somebody else's problem. And this separation of concerns is very much the key to doing TDD with external dependencies. But as we'll see, it's also very much the key to scaling up TDD to these real-world, complex, multi-layered architectures that have lots of external dependencies. So we've sort of separated off one problem, how to fetch the information, from the problem that we're actually testing, which is how do we add movies to the library with that information. So that's a stub. A stub returns hard-coded test data so that we can test our logic using other people's data. We essentially make the source of that data somebody else's problem. It will return whatever data we tell it to return in the test. So it's part of the setup of the test. Now, that's useful when we need to fetch data, but sometimes when we talk to external dependencies, we're not fetching data, we're actually calling commands. So this is what happens when we have an external query, what happens when we have an external command. There's a second requirement in our movie library that when we donate movies, the members of the library are informed about this new title that's been added to the catalogue. Now, that's going to involve sending an email, which is another external dependency. And as with not wanting to connect to the IMDb API as part of a unit test, I also don't want to actually send emails in order to test drive the implementation of logic that tells some other thing, some separate concern to send the email for us. So we're going to imagine that there is an email server, and we can tell it to send emails, specifying the template for the email, specifying the distribution list, who are we sending it to, in this case all members, and specifying any extra information that needs to be inserted into that template, in this case the title and the year of release of the movie. Now, to do this, we're going to need a different kind of test double. This isn't a stub because we're not returning test data. We're going to use something called a mock object. A mock object is something that allows us to test that a method on some interface was invoked, that a method was called, that a message was sent. And I'm going to do this using a Java library called Mockito. You don't need to use Mockito. You don't even use a mocking library. Mock objects can be, just like my stub is hand-rolled, you can very easily hand-roll mock objects. All it is an object that implements the interface that the class we're testing expects to talk to, in this case email server, and internally it just remembers when its methods are called, so we can query that, we can assert that later. Was this method called? What were the parameter values it was called with? But we don't have to write our own because there are many mocking frameworks that will do all that for us. So I'm going to import a dependency now for my project here. Let's go to my module settings. We're going to add a library from Maven for Mockito. Let's see if we can search for that. Maven searches, by the way, if you're one of the people maintaining that, please speed this up. Takes far too long. Right. It's not found it. That's annoying. Let's try again. Okay, I'm just pause for 1 second, and I'm just going to quickly Google the information I need to do this. So let's go for Mockito 1.9.5. Okay. Aha, okay. So it's org.mockito. Mockito all. So this is a distribution that pulls in all of the dependencies 1.9.5. There we go. So that contains everything that Mockito needs to do its job. Right, now that we've got Mockito, we can start writing a test with our mock email server. Note that here I am not testing that we do this inside, even though it's the exact same setup, the exact same action. I'm going to write a separate test because our test should only have one reason to fail. So there shouldn't be one test that's about whether or not we added the movie with the right information and whether or not we called the method on email server. So donate. Okay. Members emailed about donated title. Okay, now assert first to work backwards, but with mock objects, the assertions, they work slightly differently. So it's not assert equals or anything like that. It's actually a static method in Mockito called verify, and that's going to verify in our mock email server that a method has been invoked. And let's call this method sendMail, or just send actually will do. And what we're saying is it should be sent with certain information. First of all, the name of the template that we want to use, which is new movie. Secondly, we want to tell it who to send it to. In this case, all members is the name of the distribution list. And finally, there's going to be an array of extra information. And in this case, it's our movie title and the year. So that's information that will be inserted into our template. Okay, let's import that method from Mockito. Oh, many verifies. There we go. That's the one we want. Okay, now, again, working backwards, let's create our email server. So what I'm actually doing here is I'm defining this interface, and I'm doing it from the outside in, from the client's perspective, which is the way that interfaces should be designed. So whether you're designing APIs or internal interfaces or web services, they should be designed from the client's point of view, from the outside in. So they only expose the features the client needs to use, which is the way to do it. So if you think about it, mock objects are a tool for designing these interfaces. What methods does our email server need to support? Well, it needs a send method, and it needs it because that's what we want our client to tell it to do. So it's all about what things does our interface have to support, designed from an external perspective. And we did the exact same thing with the stub. You'll notice I didn't define the method for fetching information until I actually used it inside the library. So the library decided I need an information for fetching movie info. I need a method for fetching movie info. So it's from the client's perspective, which is a really good way of doing it, from the outside in. Okay, let's define this interface in our source code. Remember, this is source code, not test code. And our stubs and our mocks are part of the test code. Let's use mock here. So in Mockito, I can just say, generate an implementation. Oops, not that. Generate an implementation of our email server interface for us. So it saves us a lot of donkey work. And that implementation will record when its methods are called. No, I did not mean to do that. I meant to import it. Okay, hopefully. Now, this is where the rubber meets the road. What it's saying is there's no such method as send. So what we'll need to do on our email server is define that. Not quite sure why it's not doing it for me. Am I missing some? Title and year, I suspect, is what's confusing it. Okay, let's do that. Okay. And at this point, it doesn't matter, just as long as they match. Okay. Like that. Okay, now there we go. So it essentially does the work for us. It says you need, let's rename these. So this is the name of the template. This is the distribution list. And these are, let's call them params. Okay, so they're inserted into the template. Okay, now, at this point, it's kind of as it was. We need a library. We can probably do this all in one. And also, we can't have our movie info object be null. So what I'm going to do is a little trick here. I'm going to mock it. You'll see why in a minute. So that has to have something. Actually, no, I can't do that, can I? Because let's use our stub. Yeah, use stub movie info. And we need the title. And the reason I'm doing this is because we do need a title in a year. Otherwise, this isn't going to work. And we're going to have to pass this. And okay, and then here we can do it all in one line, and it doesn't actually matter what the IMDb is. It's not important because it's all fake information. We're making it all up. Okay, so what we're saying is when we call donate on that library with that movie information, this email server mock object, its send method should be invoked with these parameter values, otherwise this test will fail. So this is a test that's all about an interaction. It's an interaction test. Okay, and when we see this test fail, we should get a message that says wanted but not invoked. Let's take a look. An illegal reflective access operation has there we go. Wanted but not invoked. So what we're saying is that method should have been called and it wasn't called. So let's call it inside library. So we put it in the catalog and then we're going to have to add. So we're going to have to add our mock email server to our library. So let's do that inside the test. And our email server, sorry. Okay, let's update the constructor. Okay, and then we go into our library. Okay, now here's something very interesting. Now that I've changed the signature of that, obviously we need to pass something in here. So I can just very quickly create a mock email server. And that's because it can't be null. When we finish this, that method is going to be invoked. So it can't be, we can't just pass in null, we have to pass in something. The email server is not important in the first test. The first test is not about that. So this is a third kind of test double called a dummy. In this case, it's what's called a null object, which is an implementation. In this case, it's generated by Mockito, but it's an implementation of an interface for an object that cannot be null. Its methods are going to be called, but we don't care about it. So it's just a dummy. It's just there as a placeholder. Okay, now we've done all of that, we should be able to run our test, all of our tests, and see that test fail again. Let's just check why it's failing. One's been uninvoked. Lovely. Now to pass this test, all we have to do is invoke that method. So let's assign this to a field. Send. And we're sending new movie email to all members. And we're giving it this information. So info get title and as a string. Oh no, it already is a string, isn't it? Yes. Silly JSON and info get year. And when we run that, hopefully our tests will pass. Great. So our tests are passing. At this point, we probably do some refactoring. There's a few things to clean up, like repetitions of getting information from our hash map. But on the whole, I'm happy. Now, so we take a look at our test again, just to remind ourselves. In the first test, we wanted to test that our movie was added to the catalogue using the information that we were fetching from IMDb. And we made fetching that information somebody else's problem, separation of concerns, which means we can write a fast-running unit test and we can concentrate on the business logic, the core business logic of adding movies to the library with the right information. And this is a very powerful thing. But in doing that, we've also created a sort of a flex point in our design now, where if we wanted to, we could substitute a different implementation to fetch movie information from other sources, not necessarily from IMDb, but let's say, for example, we wanted instead to fetch information from Rotten Tomatoes. We could do that very easily without having to rewrite our business logic because we've cleanly separated that concern. So from a design perspective, when we use stubs and mocks, we tend to find that we end up with designs that are more flexible, that they more cleanly separate the different concerns of our system. And from an architecture perspective, that makes change easier going forward. It gives us more choices, as well as making it easier to write fast-running unit tests involving external dependencies. Similarly with our mock object here, if we decided that we wanted to send emails by some other route, or maybe not send emails at all, maybe we want to send text messages instead, then we have that option now because we've cleanly separated that concern. In both cases, we've designed the interfaces for fetching movie information and for sending emails working from the outside in, which means that these interfaces, these pieces of this jigsaw, are guaranteed to fit because they were designed from the client's perspective in tests that were written directly from customer requirements. So we're kind of having our cake and eating it here, in the sense that we're working from the outside in, but our tests are working at kind of one layer, one package of the system, one layer of the system, if you like, which is in this case, the core business logic of our library, without involving the other layers. Now, what I would then go on to do, having got my library working the way the customer wants it to work, because I'm obviously not done yet. We're not actually fetching information from IMDb. We're not actually sending emails. So there's more work to be done. So what I would do is I would move inwards, drill down one layer into the call stack here to the next sort of layer in the design, the next package in the design. So there would be a package for sending emails and a package in our design for actually fetching information from IMDb. And if we take a look at what this high-level design might look like, so there's lots of different passages. Let me just put this into presenter mode so we can see this diagram nice and big. So imagine in the finished system there are a bunch of different packages on our system, and each of these packages has an external interface. Think of it as like a mini API, an internal API. There's an internal API for the library, the core logic. There's an internal API for the email server. There's an internal API for the movie information. And they, in turn, may use other packages. For example, maybe when we send emails, we actually stick them on a message queue to be sent later. So there might be a package of helper classes that actually do that job. So imagine these packages. Think of them as like internal microservices, if you like. That might be a cluster of internal private or internal classes exposed through an API, an internal API, like email server or mail queue. And what we would do is we would write tests around each of these packages. So our tests are not all at that high-level external point of view. They are, to some extent, internal to the system, but at these internal package levels. Think of these packages as being like internal microservices. So we're not just testing one class, we might be testing a cluster of classes. Our tests wouldn't know about these internal helper classes. They would just be working directly through that sort of internal API. So they would be much more decoupled from the details of the internal design, but also better at pinpointing where things have gone wrong. So if if I do everything through the library, then if something goes wrong adding to the mail queue, the message queue, then I've got a bit of a problem, because now I've got to go on a bit of a bug hunt through the core stack, through movie library, through email server, and down into message queue, that package, to figure out where it's gone wrong. If the message queue has its own tests, testing through the mail queue interface, then it's much easier to pinpoint where it's gone wrong. At the very least, we know which room in the house the gas leak is in, if you like. So what we can do is we can drive these kind of complex enterprise designs, if you like, through an external interface, working directly from meaningful tests, customer requirements, outside in, but by driving the design of lower layers, internal layers of our system, internal packages, using stubs and mocks, we can effectively defer their implementations. We can fake them until we make them, but define what they look like from the outside, from the client's point of view, so they only have the features we need to give the customer what they want. And this is very much the key to scaling up TDD. Working from the outside in, using test doubles to pretend to be these internal packages, these helper packages that represent separate concerns to the concerns that we are testing. When we test the library, we are not testing that we can send emails. We are not testing that we can add things to a message queue. We're not testing that we can fetch things from IMDb, or that we can unpack or movie information from, say, a JSON format into another format like a hash map. So it allows us to drive these complex designs from the outside in, but to also have tests that pinpoint at the very least what cluster of internal classes, what internal packages the fault is in. So they're much better for debugging. And we're designing things from the client perspective, from meaningful tests, from the customer's point of view, if you like, directly, so we end up with pieces of the jigsaw that are guaranteed to fit. So real-world enterprise TDD is a mixture of these approaches. There's some element of inside out, in the sense that we are planning to some extent what these internal packages are going to be. So a bit of high-level design. We're not thinking at this point about internal classes and methods. We're just saying there are these key responsibilities. We can package them up in this way. The movie library, which is the business logic, the email server, the message queue, the movie info package, the IMDb client. This is what they do. And they're going to have these kinds of interfaces, so these high-level interactions. But internal to these packages, It's going to be kind of old school TDD where we drive it from the outside in, and a lot of the design will happen through organic refactoring. The design of the email server package will emerge organically by refactoring what's hidden behind the email server interface. So that's our final video. That's putting it all together. Red, green, refactor. Those habits, writing the assertion first and work backwards, even when you're verifying expectations on mock objects. And making sure that each test only has one reason to fail, and making sure that you see the tests fail before you make them pass, so you can have confidence in those tests going forward. You will have seen me doing all of these things in today's enterprise-ish example, on top of which you've seen me working from meaningful tests. I didn't go in and go, well, I've got an email server package and it's got these classes in, so I should write tests for every method in the email server package before I go on and do the movie library. No, I started with the movie library. I asked questions that the customer is interested in. Has this movie been added to the library with the right title and year? Did we email the members and tell them about this new movie? I worked from a kind of a test list, if you like. Let's imagine I did, which would be end user requirements. For example, customer tests if you work in a behavior-driven development style, or you do specification by example. So let's imagine I did that first, and that's where my test cases have come from. I've been removing a little bit of duplication, but not much. So I have not much examples of refactoring in this one, I must admit. But as we go and drill down, you would see that more refactoring would go on. So some of the design would emerge that way as well. And also, I've been working from the outside in, but I've got my cake and I can eat it now. I've got tests, eventually when I finish this whole core stack, tests that are better at pinpointing where things have gone wrong, but that have been driven directly from customer requirements from the outside in, with pieces of this jigsaw that are now guaranteed to fit because they were designed from the external perspective to satisfy customer requirements. So that's real-world test-driven development using test doubles. I hope this series has been of some help to you. There's a lot more to this, of course, and practice. That's where it really, really sinks in. And one way to get a lot of practice is to work directly with an experienced mentor so they can help you with all the many nuances of test-driven development, all the stuff we haven't had time to talk about. And that, of course, is what I do for a living. So if you want help getting the hang of TDD for real, then drop me a line or go to codemanship.com. Take a look at some of our courses. They're all very hands-on, so you get oodles and oodles of real-world practice, and you can ask me questions live in the room or live online, and that's a great way to learn. So hope to hear from you one day. Otherwise, there's going to be lots more videos coming up over the coming months. So please consider subscribing, ring the bell so you get notified, and we'll see you in the next video.